Okay, so it will be uploaded to the same repository, the Atal FDP 24. Okay, so you guys can, I think you already have the repository URL, everyone. So it will be also uploaded to the same. Okay, it is already uploaded here. I'm sharing the URL in chat. We can continue now.
Yes, sir. Yes, sir. Please continue.
All right. Now, finally, we have the model and everything available. Now let's proceed to the training part. So in order to train, we need the two major things. One is the optimization technique, what you want to use. And one thing we need is the loss function for the backpropagation part. So I'm going to simply use cross entropy tf dot keras dot losses dot binary cross entropy. So I want to use binary cross entropy. Okay. So from logits, let's make it true. So this is the optimization technique I want to use. Now after that, I need a loss function for discriminator, a loss function for generator. Now now let me first implement the generator loss. See, generator loss is simple. We are going to pass the fake images to generator. Okay, fake output, because generator is generating the fake output. So I will return the cross entropy once like. Okay, so now generator loss is simple. So it is basically for this particular loss is for classifying fake images as real. So let me comment it for you. Loss for classifying fake images as real. So what is the loss if we classify a fake image as real? Right now, if you see, this is a fake image. Right now, this is a fake image. If I pass this image to generator or discriminator, what will be the loss I'll be getting? This is what the loss will be calculated here. So we are doing nothing. We are generating simply an array of ones. Okay, nothing, just one array of the array of ones and then passing it to the cross entropy. Now for discriminator, we are going to pass two things. For discriminator loss, we have to pass two things. One is a real output, one is a fake. Okay. And it is going to calculate the real loss and the fake loss, and you will return the total loss. Total is basically sum of both. So how we are doing that? In the ones, like I'm passing the real, in the zeros, I'm passing the fake. That's it. See, I'm not using any mathematical formula right now because for generator and discriminator, you don't have to write any mathematic algorithm here. You just need to initialize everything so you can understand like how we are calculating the discriminator loss. You can assume. So this is particular loss for classifying real images as real. This particular loss will calculate that you're going to pass a real image and it will tell you if it is a real. And this loss is for classifying fake images fake. Got it? Now tell me. This is the job of discriminator. If I pass a real image or a fake image to discriminator, it has to tell you the loss. So it is going to tell you the loss of classifying real images as real for this one. And this is going to tell you fake images as fake for this one. Got it, everyone? I hope that's pretty clear to you. If it's still not, please let me know. Everyone, are we clear? Can we proceed? Please give me the information. So I can proceed with it if you guys are clear till here. If no, please let me know.
Yes, sir. You can proceed.
Okay. So now once we have these images, these loss functions available, now we have to define two different optimization. For optimization, we are going to define like Adam or anything you want. This is cross entropy function that we use for the loss function. And for the optimization technique, we can mention two variables will be there. One is a generator optimization, tf dot keras dot optimizers dot Adam I want to use, and same we need for generator. Sorry, discriminator. So this is the discriminator optimizer. So we'll be using, so everything will be two here, okay? Because you have two models. One is a generator and one is a discriminator. So optimization technique will be also two. So the loss function is cross entropy. We have two different loss functions calculated here, and generator and discriminator will be having their own optimization techniques, okay? Now finally we have to implement the training function. Here you can pass the images data. Now let's first generate a random noise. After generating the random noise, we have to start the gradient descent. So first thing we have to generate the fake images. Okay. First thing we have to generate is fake images. Okay. Now, once the fake images are generated, what you have to do? You have to classify real and fake images using discriminator. So I'm just using tab because we just have to call these functions now. So first thing is we need a variable discriminator. Let's implement a variable discriminator. Discriminator is equals to build discriminator. Call this. Okay. Batch size, I have not defined it yet. I'll define it. Okay. All right. Now what it is saying that we have, if you go line by line, the very first thing. So in the very first line here, let me tell you what exactly this is doing. Generate fake images first using generator. The first thing. Second thing, classify real and fake images using discriminator. Okay. And then you need the loss. Loss, basically, you are calculating the generator and discriminator loss. Calculate generator and discriminator loss. That's it. Now, finally, you can compute the gradients and apply the gradients. So we have gradients of generator and then gradients of discriminator. And finally, we apply generator and discriminator. And then you return generator loss and discriminator loss. Okay, so what exactly it is? See, it's a simple deep learning code. It's nothing we are using new here. It's a basic deep learning code. In the deep learning, how you train the model. So while training the model, first thing you call the model. So then you calculate the loss. After calculating the loss, you implement the gradient. So the gradient will be applied two times, one for the generator, one for the discriminator. That's it. So
So
everything
in
is
between the
repeated twice.
steps, we can analyze the image uh, in between these
Like what is the
steps.
generated image, na?
Yeah, yeah, generated the steps of generating the image. We can analyze in between the steps, sir. Image.
So after every epoch, I will print the image that is generated.
Okay,
Okay, I'll show you after each epoch what image it has generated.
right, sir.
This is what you were asking, na? Exactly, sir.
Sir, yes, yes.
Okay, so now let's go to the training function. We'll pass the data set and the epochs, how many epochs you want. So let's start the training part for epoch in range epochs. So the first I'll print the epoch that it is in right now. I'll print epoch, curly bracket, then curly bracket again. So in the first curly bracket, use epoch. In second, use epochs. So it will tell you out of n number of epochs, how many epochs it has executed. Now let's retrieve the image from the data set. Okay, so for image batch in data set, so first you'll get a generator loss and then you'll also get the discriminator loss. We'll print the loss. Okay, now we want one more thing. We want to see the images after every epoch. What is the image that it has generated? You can print after every epoch or after every 10 epoch. So I'll give you a better idea. After every 10 epoch, let's print the image, because after every epoch you won't see much change. So let's wait for 10 epochs and then see what image it has generated. So if epoch plus 1 modulus 10 double equals to 0, then let's create a function. I have not created a function to save and plot the images. I have to do that. So what I can do is create a function def generate and save images. Perfect. So for this we have predictions. So it will be having predictions. Correct. We don't want to do the training part. Then it will create a figure for us. Now for I in range predictions dot shape square bracket 0 plt dot subplot. I'll use a subplot so that I can show you the image. Okay, so this is my grid layout 4 by 4 by I plus 1. And what else I need? Three parameters are there. Plt dot I'm show. Perfect. And we don't have to do this because we have multiplied by 255. So cmap grape access off. And if you want, I can show you how you can save your images. So just use save fig. So it will save images at epochs. Okay. So just I'm telling you how you can save the images after every 10 epoch. Okay. Epoch colon 04d dot png and then plt dot show. So it will show the image as well and plot the images. So now in here, instead of pass, I can call the function known as generate and save. So I'm passing my generator model. It is going to generate the fake images epoch plus 1 because I don't want to print 0. If you want, you can like use 0. So it's better if I use epoch plus 1. So instead of starting from the 0, we are starting with 1. And tf.random.normal, it is just a random noise you are passing with 16 images I want to generate. Suppose this is my batch size and this is the noise dimension. Obviously, it is 100. And that's it. I think we are all set. Um, uh, 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 Hopefully it's all done. That's it. Yeah, perfect. And now let's define the epochs. How many epochs you want? Let's say 100 epochs. And there is one more variable we have, batch size, I guess. Yeah, batch size is defined. Let's define batch size. Batch size, let's make it 16. Now call the function known as train, pass the data and epochs, and that's it. So we are all set. Once I execute this particular cell, it will start generating the images, fake images. Got it, everyone? Can I execute this now? Let's execute. If we have any error or something, let's see. And you will see after every 10 epoch, it will save the images. Okay, it has started to train. See, we are getting, it is minimizing the loss. Great. Now only one epoch was completed. Now it is going for second epoch. And we have to check after 10 epoch, what is the result? Okay, if you want, you don't have to mention this condition. It's not mandatory at all, this condition. Okay, you can directly call the generate and save image. After every epoch, it will show you. But I'm saying that let's see after every 10 epoch. Okay. All right, everyone. So I hope you all are now clear with how to implement a generator and discriminator model. This is what GAN look like. This is a complete GAN development. So I was a bit of fast because in 1.5 hour I cannot be too slow and we can't implement everything with that speed. So I was a bit fast, I know, but you have this session recorded, I guess. So from the recordings, you can see what is the complete flow, the understanding of the code I gave you. And now the training is going on. Once it is trained, you will be able to see some good results, hopefully.
Sir, can you please upload the code also on GIT Hub?
Yeah, sure, sure, sure. Just
So that
let
we
me
can run.
execute this one.
Yeah, yeah. Okay, sir.
Okay. So
And
let's
sir,
see
I have
after
sent
10
you
epoch.
the image, cardiac data as well on the email. Did you
Yeah,
see? Yeah.
I saw that data, but I told you, there was more than 1,000 images was there. So I thought like if I'll be training on that, it will take a lot of time. So that's
Mm-hmm.
why I created this generic code.
Okay, okay, sir. So if I have to work on that code and generate a, network, so how will I do that? What do you suggest
Ma'am,
me to take a
same,
small batch size?
almost same code will be there. Code wise, you don't have to change anything.
And how about only the data? The data I need to shrink?
Exactly. You just need to pass the data. You just need to mention these parameter. What is the size of data you want? What is the pre-processing you want? You can mention it here. Okay.
Oh,
So you can
oh,
pass the directory folder name from here. You just can pass. I saw there was two directories. One is archive folder and there was one other directory that you shared with me, ma'am. Correct?
yes, yes, yes. Actually, sir,
So I
one was
extracted
that
the data and
DICOM image. Yeah, one was that DICOM images. And that was a big data set actually. The images were too
okay.
large. Mm-hmm.
Okay, 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 okay.
Okay, so maybe I'll get back to you later on that if I get some
Sure,
issue.
ma'am. Anytime, anytime. You
Thank you.
can.
Thank you, sir.
I hope now you guys are able to understand how this complete thing is working. You can see image at 10th epoch is saved here. Okay. Now after 20 epoch, it will save another image for you. Okay. Now let me open this. But this is a complete plot. Okay. If you want to save one image at a time, because I saved the complete graph and in that graph, you can see 16 images are there. So I'm saving 16 images at a time. But if you say, no, sir, we don't want to save 16 images. We want to save one by one. So we can do that. That is okay. So now you can see this is started to generate some images. Now see the shape. Look at the shape it is generating. But still see generator loss is too high. So after training a lot of epoch, you might see better results. Now let's see the images at 20 epoch. So these are the images at 10. These are at 20. So we have to wait till 100 epochs. We have to see the results. 100 epochs. Might be 100 epochs are not enough. Okay, don't consider like after 100 epoch we'll get the result. Might be we have to train further, 500 epochs or something. Okay, so I think I can stop the training from here so that I can share this code with you guys and you can train the code and then check for the results. I hope that's fine for you. So that in that case, we don't have to wait for the 100 epochs. I've shared this code with you on GitHub. Please go to GitHub and on that you'll be able to see the latest code here. Okay. And I have stopped the training. Once you will like get this code, just execute the cell one by one and at the end wait for 100 epochs to complete and then compare the results. And if you think, okay, 100 epochs are not sufficient, then keep on increasing the epochs. Then from 100 go to 200, then 500 like this. Okay. All right, guys. So I hope this was a helpful session for you to understand the implementation of GAN, how to implement that. And if you have any question queries, we can discuss now.
Yeah, any query from participant side?
I've already shared the code with you. Let me share this URL again in the chat. Okay. I have shared in the chat again the URL of this particular code. And see,
Hello, sir.
Yeah, yes, ma'am.
Yeah, actually, the session was very useful because up to implementing discriminator and generator, we can understand very easily. But how to train the model, it is really challenging to understand. And that we got idea today for on that. But my question is that because of the time limitations, we have used only 10 epoch. So how we can include the criteria? Then where we should stop the training? For that, any hint you can you give? And one more question, that suppose we have decided that after 200 epoch the satisfactory images are generated, then these images will be stored in the same directory where the Google Colab or the this notebook is there, or where it will get stored, or we have to provide the path somewhere.
Okay, ma'am. Let's answer the first question. The first question is that if you are going to train a particular model and you have a particular loss, because see, there is no accuracy, correct? In GAN, there is no
Mhm.
accuracy like 90%, 99%. There is no accuracy because we are not doing the supervised learning. This is unsupervised. So the only parameter we have is the loss parameter. So there are two things. Either you have a threshold that this is the minimum loss I want, 0.05. This is the minimum loss I'm expecting. And you can easily just track the loss value that you are getting. Okay, once I get 0.05 loss, I want to stop the training part. Okay, for that you can use callbacks kind of functionality that is available. So in callbacks, you can define like there is early stopping, there is callbacks, like how you can mention like, okay, after this particular loss, I don't want to train further. Okay,
Mhm.
so if you want to go through callbacks concept, you can easily understand there are 2 or 3 line of code maximum that you have to include here.
Mhm.
So in that you can even change the learning rate on runtime, and you can mention that after 3 or 5 epoch, just stop the training if my app loss is not optimizing. So these are kind of things we can do.
Okay.
For the second one, the images are stored in this collab only. Here it's not stored in Drive or somewhere. If you want to store the data in Drive, so instead of saving images directly here, if you can see, I've written image at epoch. So it is saving the images here. You have to connect Google Drive with Google Colab. And then you can mention something like this: content, my drive, then images, something like this. So this is the
Okay.
path you can give. Once you connect, just click here. This is the icon you can click here so that Google Drive will be mounted with the Colab, and you can pass the path something like this.
Okay.
Okay, ma'am.
Okay,
So
sir.
it will be saved to
So
Google Drive then.
one more question. Suppose where I want to generate say 200 images for my artificial images, then that thing where we can mention here, is it like the place of 16 or?
No, no, ma'am, if you want to generate 200 image, what I'm doing here, if you see, after every epoch, I'm saving images. Okay, 16 is the batch size. So you can
Huh,
understand in one epoch, it saves 16 images. How many
okay.
images you want to save every epoch? One image per epoch, 10 images per epoch. Accordingly, you can calculate. So you are saying I want to save 200 images. So you have to understand in one epoch, how many images you want to save. You can like use 200 epoch and in each epoch save one image. It's up to you. Or if you're using 100 epochs, so you can mention here two. So in each epoch, two images will be saved. So after 100 epochs, 200 images will be there. Correct?
No, sir. After completely the model is trained, then I am going to generate the. Suppose I want to generate the 200 fake images.
Okay. After training
Yeah.
completion.
Yes. Yes, sir.
Okay. In that case, what we have to do, ma'am, is we have to save the model first. Because see, right now the drawback of this code is if I close Google Colab and if I'll come back, it has to restart the complete training part and all.
Hmm.
So
Hmm.
first you can simply save the model with you. Once the model is saved, obviously, ma'am, see, the thing is we have not mentioned that how many images we want to generate. We have mentioned only one. In the generator function, it only generate one image at a time. See?
Hmm. Yes.
So here you have to change then because we are generating one image at a time. So that's what it is doing. 64 by 64 by 1 you will get. So
Hmm.
we have to change a bit of model that I don't want only 64 by 64 by 1. I want n number of images to be generated. That we can configure it in the model part.
Okay. So in model part only we have to configure. Uh, It is not like that we will be after training we will be running the generator part, only generator to generate the 200 images.
Yeah, we have to only generate, we will save the generator model. And once the generator model is saved, let me show you one statement that we used above here, ma'am. See, here what we did is I am passing only one. So it is generating one image. If I
Hmm.
pass here five, it will generate five images. If I pass 10, it will generate 10 images.
Okay.
In the predict method, you can pass that how many images you want to generate. Okay.
Okay. Okay, sir. Thank you, sir.
So at the end, you will be having output 64 by 64 by 1, but instead of 1, you will be having n number of images. Like if I write here 10, so the
Hmm.
dimension will be 10 by 64 by 64 by 1. So 10 is
Okay.
reflecting the number of images.
Okay, sir. Okay. Thank you, sir.
Sir, now we can work on these images. My GAN is generating these images with minimal loss, and now we have to work further on these images.
Yeah, we can combine this with the data, or we can
Or
use
we
only
can
these
use a
images up to the
segmentation or
requirement.
something that will give us a better accuracy.
Yeah, correct, correct. Whatever, like our requirement is after that. We just wanted to generate the images using GAN.
From the normal data set, these images will be more better, right?
No, we won't say better because we will say, yeah, they are equivalent to that. Because
Sir,
by
then
better,
why are we
obviously, the real
using this?
images are a
Why
better
are we
one.
using this method? That is my question. If they're equally better, then
Lack of images. I have only 100 images, but I want to train my model on 1000 images. So I can generate fake images and then I can train my model.
okay, sir. Thank you so much.
So can we use this GAN in image enhancement?
Yeah, image enhancement, we use GAN, sir. I don't remember the model name. There are a lot of models. Let me share one website with you all. TensorFlow GAN. Just go to TensorFlow GAN. Okay, you will see different type of GANs are available. So there is a pixel to pixel, and also these kind of GANs are there. So you can pick up anyone. And these are the mainly used GAN techniques we have. And definitely, sir, there is a super resolution GAN. It's not available in this documentation part, but there is a super resolution GAN, very popular technique to do the images enhancement.
Super
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 resolution GAN.
resolution. Okay.
Let me show you. Okay, so you just search super resolution GAN. So you'll get an idea that these are some popular models that we have for image enhancement. Might be
But
we'll be having some better. This is in 2022. Might be we'll be having some better models now, sir. But this is one of the model I used earlier.
in case of uh, image enhancement, there is no ground truth image or reference image.
Mhm.
There is no ground truth or referenced image. Then how we get the desired image?
Sir, by default, the images you will be passing na with poor resolution. With
Okay.
low resolution images, you are going to pass na
Uh, and
as input.
okay.
So that
And
is my ground truth.
how can we compute this loss angle if both
Now
the
it depends
images are
which
poor
model you are
resolution
exactly using.
images? Yes.
Yeah, yeah. Actually, sir, it also depends which model you're using. So there is like data augmentation better GAN. I'll be coming to that question. So if we are using simple super resolution GAN, so we have the loss functions and all. Based on that, we can easily understand that the loss is high or low. So based on that, we can do that, sir.
Okay. The discriminator input is poor resolution image, and your generator input is the noise. Then how we
That
get
will
the
enhance the images.
that will enhanced?
Yeah, that will enhance.
Okay,
Even
sir.
there is one model. It's a long time I have worked with these model, but there was one model.
Mhm.
Uh, let me scan models for image enhancement. I have to search. Mhm. Actually, there are multiple models at that time I was familiar with. I don't recall the name exactly, but very useful models were there. I'll check the names and I'll share it with you, sir. Because I don't recall the name exactly now, but there are multiple models that are available. See, this one is the popular. I already told you, super resolution GAN. But other than super resolution GAN, there are a few more models that you can use. Okay.
Okay, sir.
Data augmentation better for GAN. Now the point is data augmentation is implemented on a particular images that you already have, but we are using GAN to generate more and more images. If I say I have 100 images, you apply data augmentation like you rotate, flip, these kind of things we are actually doing. But still, almost, if I talk about the features of the image, are we changing the features a lot? No. If I simply flip the image vertically, horizontally, rotate it or something, doing these kind of a thing, I might get number of images increased, but the feature wise, if you talk about feature wise, I have not much improvisation available. That's where GAN comes to the picture. Getting my point here? If I ask you, can fake faces? If I ask you, we have to create face recognition system using GAN. We have 100 images. And after using 100 images, you are saying, sir, let's do data augmentation on those 100 images. Can you change the feature of the face using data augmentation? I don't think we can change the features, na? But if I use GAN, I can generate fake faces. N number of fake faces I can generate with different features. And then I can use that data for my training purpose. This is the advantage here. Getting my point here? So this is going to be beneficial for us in that particular case. But again, this is a like catch here. If I don't want to change the feature, I want to use same features, then I can use data augmentation. Okay. I hope we are clear till here. So I have shared this code on the Git and shared the Git URL with you all in the chat also. Now I think we can wind up the session if no question queries are there.
Yeah, anyone having any query, then please ask. Sir is explaining very well. Sir, this type of system can be used in remote sensing images, sir. GAN.
Sir, yeah, I have seen some like in like 2021, 22 might be that year. I don't remember exactly, but yeah, I have seen some implementation of GAN for remote sensing images as well.
Okay, sir. One of the participant asked in this chat that what is the application of GAN?
Application of GAN, obviously the first one already sir asked one good question, that was data enhancement, image enhancement.
Yeah.
Image enhancement is one of the basic, I won't say the basic, it's now become a very good feature now that we have. Now let's talk about one application. Do you remember one mobile application that came, Face app? Now that using Face app, it generates your face, like how you will look like after 60 year of age, or how you might have looked when you were a kid of 5 or 6 year. Do you remember this application? And sir, remember? A lot of celebrities were using that application also, like how they will look like if they are above 60 or 80, after 30 year you will look like this. So kind of these applications were introduced. It is used in camera applications a lot. So they are, the image enhancement is already implemented making your face amazing. That is GAN. Obviously, now we have Gen AI and all, but before that, it was everything was implemented using GAN. They generate the fake faces in, they are not applying the
Yes.
filters on the face. Okay, if I
Mhm.
want a beard filter, so I will use a Snapchat. It will apply a beard filter on me. But GAN will integrate the beard in your face and then show a new face with a beard. That's the GAN. So a lot of applications are there like image enhancement and all these kind of things are going on. So they generate the images on runtime and show you the outcomes.
Yes, sir. I think some of the more applications in image segmentation.
You are asking me, sir, more applications about GAN?
Yeah, more applications. Yes, sir.
Okay, one thing I shared with you guys, I think I did not share. Let me share it with you. You'll get a pretty good idea from here. If you'll go to this website of TensorFlow, I shared this URL with you. So here you can see some examples are there of DC GAN and all, pixel to pixel cycle GAN. From there, you'll get idea of how these applications are created. Just look at these images, how they are predicting the images, how they are generating these images. Look at this ones. So one of the main thing is it is generating the cartoon characters right now. There is one topic known as image to image translation. I don't know if you guys have seen that. Image to image translation, if you guys have seen that, what exactly that is, GAN can easily translate images from one particular domain to another, like converting a photograph into a real world scenario, like these kind of thing. Text to image you can do, or we can like generate new poses, emojis that is being generated, photo blending, super resolution. So all these things are implemented based on GAN.
Okay, sir. That's fine, sir. Sir. Uh, any other question
Anything
from
else?
participant side? I think question is over now. And Preeti ma'am, over to you.
Thank you, sir. Swati here.
Swati
So,
ma'am.
thank you very much, sir, for this knowledgeable session. Hope participants have learned many things from you, and hope to see you again with the join you in some other session or in some other day. So, thank you so much, sir. Now,
Thank
I would
you.
like to introduce next speaker of the day, who is we are delighted to welcome back Shivam Tyagi, a distinguished IT professional with over a decade of expertise spanning payment, telecom, and hardware design. Currently, a software development engineer at Amazon Payments. So Amazon Payments. Shivam leads the groundbreaking initiative that harness generative AI and data analytics to revolutionize global payment state system and enhance enterprise efficiency. We welcome you, sir. Over to you, sir.
Shivam sir.
Shivam, sir, are you there?
Yes, sir, I'm here. Okay. Please don't mind my appearance. I just woke up. It's very early morning for me. So, but yeah,
Good morning,
thank you.
sir.
Good
Good morning
morning.
to you,
Thank you
sir.
for inviting me here again. Uh, and yeah, I think today we will go over the image analysis is what I'm targeting
Yes.
with the folks. So we will need some prerequisites and we can also work. So I think some time will be taken up in setting up those things. So, but yeah, thank you, Nitin sir, and all the esteemed faculty members, dean sir, director sir, for this opportunity to interact with you all.
Thank you. Thank you, sir.
Yeah,
Continue
now
with the
I will.
session, sir.
Thank you. So I will share the screen quickly. So FDP session 2, yeah. So what I'm targeting today to work with you all is hands-on exercise for some aspects of image analysis, and for that we will need Jupyter notebooks installed. So I think we will need communication on the chat. If like you guys have it installed, if someone does not have it installed, then we can will wait for that. Okay, never mind. Okay, yeah. So what is image analysis? In very simplistic terms, is extraction of meaningful information from images. This can include identifying objects, colors, activities, context, text, and why is it important is I don't think in this session we have to tell that, but because this is specifically for image analysis only. But yeah, utilities are limitless. There is no limit for this. You can use it for security, you can use it for healthcare, you can use it for environmental, to study environmental changes, and education. Whatever sector you can pick, you can use this image analysis for that. Goal of this session is to understand how it works. Do we have something that is so exclusive that you just give it an image and it gives you all the details? If it is, what is there under the hood, right? What is there that is how it is working behind the scenes? Presentation format will be the same. We will develop the PPTs as we go, just like the last session. And so after from this, the slides will be just a topic and fairly empty, and then we'll develop those PPTs going forward. Okay. So understanding the key components for image analysis. What are the things you think that we need for an image analysis? I will give you an example, and then I would like to know from you all also. So I want to make it interactive because it's very early morning for me, so I may feel I can sleep again if you guys will not keep me awake. So like one is object detection. So right, like if you have an image and then you want to know there, it can be of different types in the sense that do you only want to know the one object, or do you want to know multiple objects? Do you want to know one type of objects? Like, okay, I want to know all the vehicles in this image. I want to know all the living beings in this image. I want to know all the plants in this image. Or do you want to know multi classification in the sense I want to know what are the vehicles and the plants in the image? So it can have different flavors, but that is first step that we one of the operations that we can do from image analysis perspective. What can be the second component of this? If anyone is willing to can participants turn on their mic? Nitin sir? Participants are not allowed to turn on their mic, right, Nitin sir?
No, sir, they are allowed. They can turn on their
Oh,
mic
they can
if
do?
they want.
Got it.
Yes.
Yeah. Okay. So yeah, I will wait for like 4 seconds. If anyone can would like to unmute and just do some brainstorming with me, what are the key components of object detection? Then it will be fun.
Rohit sir, please allow the participants to unmute yourself.
Sir, they are already allowed, sir.
Okay, okay. But
Features of the object?
Key
Feature selection
components
is one.
for features. Yes, ma'am. Thank you. Very nice. Definitely. Features of object. What can be the features of object? Like colors, right? Maybe size, length and breadth.
Can be age,
Those. Sorry?
ages of the object.
Edges. Edges. If I heard it correctly. Edges. Okay.
Texture.
Yes. Texture. Correct. Good. Next one I can tell.
information, entropy.
Shape.
Shape.
Shape,
Oh my
sir.
God. Definitely. You guys know so much about features, huh? Very nice. Okay, yeah.
Information, sir. Information, entropy.
Shape, information, entropy. Yeah.
Color.
Color is already there.
Color is covered, ma'am. And got it. And so that is, we can call it as object analysis. So one is object detection, then object analysis. Okay, let's say. Yeah. Now another step for this can be scene recognition. You know, where is the object actually? Is it outdoor? Is it indoor? Or right? So those type of details we can gather. And then last, probably that I will cover at least for this hands-on is activity detection. Running, walking, sleeping, right? What is the, if we are talking about a human, if there is another activity like driving or flying for bird, then we can also have that. So we'll go through this four kind of key components in our hands-on. We'll do some how to through a code piece for object detection. I will share the Jupyter notebook. So once we are done with these slides, we can quickly work on setting those up, but you can install Jupyter notebook in parallel if you don't have it. Okay. So scene recognition, activity detection, object detection, and object analysis. Or we can also say we will only do color analysis for this session, but yeah, you can do other things also, like all these great points that you guys shared. Okay, a step-by-step process. Let's do this. So what will be the first step for an image analysis? what is the first point that comes to your mind?
First, you need to read the image and pre-process it.
Exactly, sir. Perfect answer. Yeah, load and pre-process the image. Correct. So we will use some libraries to do this. Like there is OpenCV is a library, OpenCV. Then there is another library what we call as Pillow, which are there to do this problem for us. Okay. And what is the one step, like how we do it is, like how one example of pre-processing is like converting the image into its RGB format, right? What are the, like I was telling in previous session, that we need to have a mathematical representation of the image to put it as an input for any machine learning model to process it. So how we'll do by using the RGB values of each pixel. So that is one example of pre-processing the image. And then step 2 will be, like we said earlier, object detection. For this, we will use libraries like what we call, let me put here only, Dieter or YOLO to identify objects. These are pre-trained models, or you can say that you can download and then run an object detection on your local system itself. So yeah, last session we talked a lot about training and then pre-training, but yeah, feel free to ask any questions on that. So these are, you can say, they are not large language models, but they are pre-trained models that we can download on local and run. Then there is a concept in object detection which is called bounding boxes. So what it does is it tries to create a window and then analyze the pixels in that window. And based on that, the model tries to infer what its understanding is from the colors itself. Extract colors from the object using either OpenCV or you can do K-means. K-means is a good algorithm to extract colors. It will form the cluster of the similar colors and then give you, okay, these are a list of colors that are available in this image. And there can be a red shirt, there can be a green trees, so like that. So it can cluster objects based, or like the pixels based on that, and then identify the colors. And then if there are, based on combination of colors, it can tell if it's a shirt or tree. So like that we can use it. And last but not the least, summarizing the image. Summarizing the image. So we will process the image, load and pre-process the image. We will detect some objects, try to detect what are the objects present in the image. We'll also look into the colors that are available in the image, and then also the scene actually. We will also check for what is the setting of it, scene details, right? Scene detection. And then lastly, we will combine all these above informations to create a summary of that image. How does it looks like? I will quickly go over different tools and libraries that we will use. So like I was telling, for object detection, we will use DETER and YOLO. Okay. So what are we going to do? Object detection. I will go, yeah, it's morning, I'm slow, so please don't mind. So DETER, which is nothing what we call as detection transformers for end-to-end object detection. And then YOLO is for real-time detection that you can use. YOLO's full form was, I'm forgetting. You only look once. Yes. Okay. Yeah. So yeah, so these two libraries are very much used in object detection, for object detection, especially if you are doing it on your local machine, right? So these, because to run on local, you need some lightweight models and libraries that can run effectively and quickly. Then for activity detection, or what we call as pose and activity detection, we'll use MediaPipe, which is a library to detect human poses and also the landmarks. So basically you can analyze a human image and check if the, so it basically checks if the what is the pose of that human being based on his stride, is he running or is he walking. So those type of analysis you can do using this library. Color analysis is this so we already went through it, right? We will use OpenCV for this, and also k-means clustering. Detecting dominant colors in the objects. Like it can be an object can have multiple shades of the color, but you want to we don't have leveraged, or we may not have need to know everything, so we will kind of concise it into some groups and clusters. So that is where k-means come into the picture. So it will combine probably all shades of red into one single cluster that is red. That way it will help. And then we will also, I will also show text detection. Probably we'll see. That is like if you have an image that has text, it's pretty much easy to do to identify that text from that image and list it down. Now yeah, but what we will do is create a so for summarization we will use GPT 4o model. I will provide a key to use the model from my account after the session. I will show you how you can also get that. After the session, that key will be deactivated. so you will not be able to use it. So, but I will show you how you can create your own ChatGPT account, and where you can go, how you can create the account, and you can add your some you need to add some payment method and buy some credits to make API calls to ChatGPT models. So what we will do, we will take all this information that we have done above, and then we will ask the GPT that if it can create a summary for us. So essentially what we are seeing here is there is not one model that can, like, okay, or one API call, you give it an image and it summarizes. There is not a single model that can do that from my experience. So what we do is we combine different models. Okay, this is one model that does object detection, so let's use this to identify the objects. Then this is another model that that is trained to identify the pose and activities, so let's do that. And then there is another model to identify the colors, and then we combine all that information and ask another model, maybe an LLM, to generate a summary out of that information. So this is also gives us more control, because you can test with accuracy of each of these steps. You have one model, and which is, let's say, trained in all these, one model that can do all of these, but you cannot play that. It does not gives you a lot of capability to work on each of the aspects of it. Like, what can you do? Can you do some hyperparameter tuning? Uh, uh, just to improve the object detection. Then if you have one model, that is easy, but if you have basically separate models, then it becomes easy, scalable also, in my opinion. And if it's one model, then one hyper tuning, hyperparameter change can impact all the aspects of the analysis. So that way you have like a decoupling between different aspects or different steps, and hence more control on accuracy and performance of each of it. Okay, I will just take a quick pause to see if there are any questions. Oh, this slide came early. Okay, we can quickly then discuss about some of the real world applications, like we also quickly discussed earlier. Education, healthcare, environmental science, and projects, definitely medical field, where you have to say analyze an X-ray object. You can use this image analysis to get details from it. We'll do a very basic one, like identifying the part. We'll do an exercise where we will identify that if there is an X-ray, what is the part of the body that it is off. And but yeah, you can definitely do a further deep dive and get more details out of it. So I will give you the code, and you can play with it once during the session or after the session. Okay. Then yeah, challenges, right? Okay, we are talking, okay, it's good, we can identify this, and look simple, just identify the images, colors, poses, activities, and give it to an LLM, and then and generate a summary out of it. But then what are the challenges for it? I will just type here actually. Accuracy. How much accuracy can you attain? And then, right, models can probably misidentify objects, or if the object is or the image is too complex, they may fail totally. They may get totally wrong. They can say it's a cat when it's a dog, right? So accuracy is something that is a challenge. Then diversity of images, right? Data, the image in today can have, actually image in general can have different aspects like lighting, angles, resolution, that can affect. If you are giving a blurry image, you cannot expect the output to be very good. I mean, if it gives you, that's good, but there is high probability that it will not be. So, or the model needs more training to identify, right? So, and then quality, quality of input, I would say, quality of input. Another one is interpretation, in the sense that, okay, you have a mathematical representation of the image. We will see this challenge that when you are giving it to a model to analyze, right, it will also respond in mathematical terms. How do you interpret it? How do you make it or transform it back into a human readable form? Okay, so interpretation of the results. Okay, I will just quickly open the floor for any questions, or else we will move forward for our hands-on exercise. Okay, I assume there is none. Okay, so I will just drop a couple of files in the chat that you guys can download, and then we can work from there. And I think I am anticipating that there will be some churn because to see if it works for all of you or not. But yeah, we'll try to do our best. Where is the chat option? Here it is. Can I share a file in this? This is disabled for me. Okay. One second, let me stop sharing for a while. Okay, it does not allows me to share the file itself. But if you can everyone type in chat if they have a Jupyter notebook ready there, so I can just probably send the commands and you can run on your Jupyter notebook. I will give it a minute so that everyone can share if they have Jupyter notebook, and then we can start running that. Those who have and let me share my screen again here. Okay. Share. And So this is the Open API key. Basically, what do you need is, let me see, where is my Chrome? As you can see, I use Chrome LLM extensively for my hands-on concising my thoughts. Okay, yeah, let's see here. So you can go to platform.openapi.com, and then you can kind of create a login for yourself. And then if you go, billing is the section where it will ask you to add some balance for it to use. You will have limits listed in this tab, where you can see what is the, so GPT-4o, what is the token limit for it. Token means, I think you all already know probably the words. We also went over it in last session. And what is the queue limits, and give me a second. So as the models, new models come out, they have these token limits because of their intrinsic design of transformers, and where it kind of defines the window for which you go and generate the whole metrics, you can say, in one shot. Basically, that is what the biggest, in my opinion, the biggest advantage of transformers is, because it allowed that parallelization that neural networks, sequential neural networks, were not able to give us, right? So you can definitely explore that. Yeah, so this is token per minute, request per minute, right? And this is probably token per day. I don't think so. TPD is what? Oh, tokens per dollar. Wow. Okay. Yeah. So how many tokens per dollar you can have? Okay, interesting. Yeah. So this is the limits, and then you can kind of come here under you can add a project, and project have keys like this one that you can create a new secret key. And this is the key that I will share with you guys to make a call to my model in my account, and hence you will be able to make LLM calls to OpenAI. So once we come to there, you can have a limit limit you already have, but you can also limit the models that are allowed, in the sense like here I have done GPT-4, Omni, and text embeddings, but you can enable other models also. Basically what you want to do is optimally utilize the credits that you have. So there is some place where you can check how much money it takes, like oh, probably it was here only. No, okay, never mind. So it tells you that, okay, for GPT-4, if you send it 100K tokens, this is the price. If you use it for some older model, that may not be that expensive. So based on so basically what happens is, newer models or latest models, more capable models, are little bit more expensive than the old models. But it gets expensive when you work on scale, in the sense that today's session will not even consume probably the whole $8 or that I have still in my account, right? But if it's a website that is getting a lot of traffic, then yes, definitely this will not be sufficient to probably even for a minute or so. So it depends. But yeah, so you can use this platform.openai.com to create your own account, add your own payment method, create your own project, and then add some money, and then only, because otherwise if you will make a call to OpenAI models, APIs, they will give you access denied errors. Got it. So just quickly moving over, we will need some libraries to install for our this. I will work on a new notebook for you guys, because I already have the run, but I will probably just copy paste so that we see step by step what we are doing. I will share the API key when we will need it, but I think for now we don't need that. So I will share it when we'll be there. Yeah, so this is what we need to install in the starting. So I will just put them in the chat. If pip3 does not works for you, you can remove the 3 and just do pip install. Like here, you can do pip install. Some people also download pip x, so you can also sometimes use pip x here. So if it's already there, it will probably say required already satisfied, or if not, it will install these libraries. Yeah, please feel free to put message in chat if you face any problem and you want me to stop or take a pause, and if we go for too fast, in just in case. Okay, once these libraries are installed, yeah, we install transformers like I was telling you earlier. We'll see what are, so based on what we will import from them can give a good idea what we are doing. So this is pillow. Probably someone will face a error in this, that PIL is not found. So let me know if that's the case. I think you guys are doing a lot of image analysis or image related things in this session. So maybe you have it, but if not, then you can install it. It should be similar, pip install pillow or something. We can take a look at the Google probably quickly, and then I can share the command. Oh, sorry, let me put it in the chat. My bad. Yeah, it should be pip install pillow if it gives you this error related to PIL is not found. So if you, this is a good thing to observe. We have this is the OpenAI client that we will use to make a call to OpenAI ChatGPT model, GPT-4o model. And then and then clip processor, clip models are related to understanding a text in an image. Essentially, it will help us to pre-process an image into its RGB values. Are we good till here? Anyone, sir? Please share the entire Python notebook. Oh yeah, sure, I can do that actually. Actually, yeah, it didn't allow me to attach the file. So if it's only with admins, I can share it with Nitin sir, and Nitin sir can drop it here.
Yes, sir, no problem. You can you WhatsApp me.
Okay, sure, sir. Let me
Shared.
do that. Okay, let me quickly stop sharing. Okay, Nitin sir, I have shared it with you. It has some garbage also. So just a disclaimer, because I was doing some more experiments.
Yeah.
So
Okay, sir. No
probably
problem.
it has some these type of comments. So yeah, but I don't think that should be a problem. Your first cell will not run because you don't have a open API key essentially. So like I have this environment file .env where I have my keys. So if you load OS environment open API key, you might not have that key here. So it will probably not work out of the box.
Shared with the participants. Please check your WhatsApp group.
Yeah. Yeah, so we were at the step for these, and then we'll create a client for OpenAI calls in this one. You can use any image, like here I have test image. You can use any image path like this. Probably I would recommend wherever you have the notebook, just have an image then and there itself. So that you don't have to go like a path thing that it is in this directory and all. It should run out of the box for you. Like I have test image in my directory here itself, just by the notebook. Like I said, we need to load and pre-process the image. So this is this image package from PIL or Pillow allows us to basically convert, read this image and work with. And I think a good thing always for learning is to print things in sometimes to give you in visibility into what does it even looks like. So like if I run this code, oops, sorry. So it prints the image for me, how it read it. Now let's uncomment it here. Now this will not work because here what I'm doing is I'm trying to extract a text from this image, which it does not have, right? So let's see what does it says. Do we even have a text? Is it, can we fool it to identify a text? Right, so you see it was not able to. Okay, so this is basically to extract text from an image. Okay, we can probably go on. So let me see if I have any other. Never mind, I don't think that is required. So if you have any image that has some text data, you can play around with it and see if it is able to identify, like if you have a prescription image or if you have an X-ray image with some more details on it that you want to extract. Can you use this to extract those textual data from the image itself. And probably comment this. This will, as I said, it will not work right now because for this client, you need that key, the OpenAI key. So that I will share going forward. I'm just not sharing it to avoid, like let's say we use it and then the credit, we run out of credit. So that's why I'm holding on to it for now. I will use it when we will really use. I will share it when we will really use it. Okay, so this is the first exercise that I have planned. Labeling an image using some defined classifications. So what does it means is, say you have an image and you. Oh, is it? Let me check. I think it was shared. Did I stop sharing? Oh no. Okay. Yeah, thank you, sir, for letting me know. How is it now? Can you guys? Is it visible now?
Yes, sir, it's visible.
Okay, great. Sorry, my bad. Okay, yeah. So as I was saying that this is basically this was the first cell that I was talking about. So I was telling that you can have this image somewhere close to your notebook, and so that it's a simple path, and then you can have open it using image library package from the Pillow. Use so this is a PyTesseract is another library which has the basically which can help you to identify or convert an image into a string. Okay. Extract the string from the image. Sorry. Okay, probably nice. Got it. Yeah. So PyTesseract helps you to extract the text from image using the OCR, and you can identify that. So like I had the image, I have an image, but it does not have any text. So it is giving me empty right now. But yeah, if you want to have analyze an X-ray image, something like that, then you can use this. Yeah, this was the exercise that I was talking about, labeling using defined classifications. So let's say you have an image. I have a lungs image here, and then we have these classifications already defined. Is it? And then what we want to do is that the model or the process can analyze that image and classify what type of image it is in these possible labels. So if you have say 100 images and you want to sort them out, that okay, what are the chest x-rays, what are the lung x-rays, what are the leg x-rays, you can use this to label those images and then sort them out in that way. So yeah, when we have an image, I can show it. It's something like this. So I will probably share this file. And you can use the same, or you can use any image from your side. That's also fine. You can also modify the labels here. Okay, if you just have your image, then you can modify the labels for identifying, say, it's a human or it is clothes labels. So based on whatever your requirement is. So we'll go step by step. So we are loading an image, right? And then now we need to have some pre-processing done. So clip model, as I was telling, we can use for this ask. So the model we'll be using is OpenAI Clip VIT base patch 2. And let me know if it runs out of the box. If it gives you an access denied error, then probably you need the key. And I can actually, let me share it now. I think this is a good step for you guys to have this. Yeah, I will put it in the chat here. So I'll give it a minute, create a .env file and just put this line in it like I have. You can have it there like I have it here, just where the notebook is, .env. And then you can run this, you can have a cell with this code to run it. So basically what it will do is whenever a key is required, it will load it into the environment. So whenever it's needed, you can, you don't have to define it, it will probably just use it. But yeah, let me know if you face any errors. We can see if I can quickly resolve it and we can help you move forward. So these are kind of some already defined methods or APIs. Using this, you can create a model and a processor for this whatever model you have chosen. Different models can have different qualities. I did not looked into what is the specialty of this, but if you have that question, you can do some research. So once you have the model and the processor, we have defined here some labels based on, you can have anything, it depends what is your field is or what are you looking for. So basically this is good because it gives you an capability to modify things at your level. If you know that you only have lung x-rays, then maybe you want to have something more deep labels. Is it an infectious x-ray or is it left lung, right lung, something like that. So you can definitely do some play around with those type of asks. All right, so this is done. Then yeah, we are giving these labels and to the processor here and also image. So basically what you are doing is what are the text inputs to the model or this processor, and what are the image inputs to this processor. So we are giving it both in that sense. All right, and then here we are trying to use the model to get the image features and to get the text features. So basically processor is processing that image, and then we are using model to process to analyze those processed inputs. Similarities. So if you see, we are using cosine similarity basically. So this is what it will use to, so like let's say it has an image. Now how it will know that it is a lung or is it a leg or is it a neck. So it's a pre-trained model, so it is already trained, and then how it uses that training is like, let's say it already knows that these are the images of lungs, these are the images of neck. It will try to find a cosine similarity between the input and the existing data that it has, and then create a match for it, and also then I like derive a label for that. Based on the similarity scores, it will identify what is the best label for that. So basically what we are saying is whatever is the maximum value, say that is the best label, and then the description that the X-ray image is classified as this. Once we analyze the image, then we ask the chat GPT to summarize it. This is not essential, I would say, because once you have the description, you already know what is the label. But yeah, you can do some more pre-processing on it, not pre-processing, post processing, to, if you want to create a description or a summary of that, this can help. So I will just run it, and then we can look at each value separately. So the X-ray indicates that it is a chest X-ray, which is a common imaging technique used to visualize structures within the chest. So I think, so like if we print the description now, right? Let's see. That the X-ray image is classified as chest X-ray. Whatever is after that, which is a common imaging technique used to visualize this, is because of this response, right? It is in that is done by GPT, because GPT is text generation. That is what we are asking it actually here, that analyze and summarize. So it is just whatever it knows about chest X-rays, it is giving us those inputs. We can also use some other image. I have one more. Where is it? Yeah, this one. X-ray skull from right side. So let me just grab the path of it, and I can provide it in here. Remove all this thing. And now if I will run it, let's see. So if you see, X-ray image is focused on neck region, because we have a neck classification here, and probably it will identify as a neck. So this is how you can use it for like I was just saying, sorting some images or like that. And now I will just quickly show you what are these inputs look like. You don't need to know, but I think having that perspective helps us to understand the complexity of what is happening behind the scenes, right? So if you can see, it creates that matrix of numbers. It creates a tensor essentially, and then a attention mask. So I will not go into detail, but these are of attention mask and all that. But it's essentially creating a representation for the image. We used what text inputs. Let's see how image inputs look like. Yeah, so I think this is basically another tensor, which is probably providing you the pixel values. So what is the intensity of light? Is it dark? Is it light? Or is it something of that sort? So any problems in running this cell specifically for anyone? Yeah, if you will let me know, because then it will help me to keep update this also. If there are any problems, then I can update this. So that feedback will help me to probably improve this. So yeah, you can type in the chat if you cannot speak. So that is also okay. Okay, assuming all is going well, then with a happy picture, I will give you guys like 5 minutes to play with this, and put some image of your own, and add a new label, and then see if you can if this model can actually identify that. And also, if you can put on the chat what are the new labels that you tried, that will be good. Bone density. Oh, wow. Okay. That's a good. We can probably have some labels or try with labels, in the sense like if I have to approach it, I will have labels of, high density and low density. Let's try that actually. If we want to see, if I remove this, right? And so based on its analysis, it should be able to tell if the image is based on the pixel values and all, that if the probably it will not know that it's a bone or something, but we can ask in a way, classify a label that can help us to make that decision. Let's see, low density. Okay, so it says that it's a high density image, right? High density. Let's see, high bone density, low bone density. Now, how correct it is, that only doctors can tell, but I'm just giving it a shot. Medium bone density, because in my opinion, since it knows the intensity of light and in different areas of this, so based on that, it should be able to come up with some probability values that how does it the bone in the image looks like. Okay, so it kind of says high bone density, and I don't know, but yeah, I think that's a good area or a good problem statement to explore. Yeah, thank you for that question, sir. Yeah, exactly. It may work, it might not, but I think it will be fun to try. I don't have a good set of images actually, or I would have tried right now. But if you have like 100 images or 10 images, and we can give it and then see what type of results it gives. Yes, of course. I mean, if you have it already, so you can train your own model, of course, that is always a possibility. But if you want to use something out of the box, which is the thought process or the mental model with generative AI, and I was trying to present that model, that thought process, that because that will be simpler or easy to start with, and that is what kind of my goal is, that I give you guys tools that are easy to start with, and hence I'm using the out of the box libraries. But yes, you can definitely train your own model, and then but yeah, you have to give it probably labeled data set or something, but you can have train a model to identify the bone density. You're right. Thank you. Cool. I will move forward. Thank you, Sachin sir, for your all the questions and inputs. Very helpful in keeping me awake. Okay. Yeah. So next I wanted to show you guys the object detection. So same thing. If you have an image, you can put. Now we are using data image processor and data for image detection that we discussed earlier. We will pull this pre-trained models from this. You don't need any API keys or anything for it. They should be available out of the box. So if you run the cell, it should download something for you, these models for you. It will take some space, I think some 500 MBs or something, but it will download these processors and models for you, and then you can just start using them very quickly out of the box. So like in this case, for object detection, I have kept the image of my daughter, and let's see, I'm trying to identify the couch and a human being here. Right. So let's go over what it is doing. It's kind of similar process as we went through earlier. We load an image. Earlier we were using the different processor, clip processor and clip model. Here we are using the data image processor and this model, data image detection model. We will create the input tensors using the processor, right? And then the object detection. Let's see what is the outputs value in this. Right. So if you see, this is like mathematical representation of the objects that we have in this. Now we need to convert it into a human readable form. So that is where we kind of post processing, post object detection process, where we give it the outputs and it tries to convert them into some images. Basically, it tries to club and come up with a not exact image, but the mathematical representation of it or the metrics for it, because after that only we box those mathematical numbers or representations and then try to identify or convert them into some images. So like you see, we have let's see, what do we have in results? Does it gives us a human readable form? No, right? So if you see, it's a mathematical representation. And then we use object based on this processing to identify different objects for it. So now if you will want to see what are the detected objects. So you see that chair is 96 probability, couch is 98 probability, there is a person with 100% probability, there is a potted plant also. Is there? Oh yeah, there is. Oops. There is potted plant, right? So it is able to identify all these things from that image. Okay, and with some probability, and then based on, I think from chair and couch, it will check which is the highest probability, and then it will give us the couch. The image features person prominently, and now based on these values, right? If you see, so we have this object description here, right? Which will probably just tell, okay, the image contains these are the following objects, and then this object description goes into the GPT prompt that, okay, this is the object description. Now you create a summary out of it. So that is where this whole, this output is coming. Just ignore the above 3 lines. The image features a person prominently. Now, how is it able to tell that it's prominent? Because there is 100% detection. There is no doubt there. So it kind of use that value to determine or to articulate in this way that it's prominent, and there is along with a chair and a couch. Now see, it probably made a mistake here. Let's see if we have a chair. Oh yes, I think so. So this is a chair, the black thing, but it should have also detected the lamp in my opinion. Anyways, So chair and a couch, both of which are likely part of furniture in the setting. Additionally, there is a potted plant included in the scene. The confidence score indicates a high certainty regarding the presence of these objects, particularly the person, couch, and chair. Right. So you see how we detected the objects. Lamp is occluded. Okay. Yeah. So and you can see how it was able to so how we leveraged it, actually different thing. We leveraged the object detection, find out all the objects, and then we gave it to the LLM model to generate a summary out of it in a more human readable form. Okay, so now just to quickly probably we'll go over a quick exercise of summarizing an image with these steps. Nitin sir, if you can help me how much time I have, it will be good.
Yes, sir.
For
10 minutes more, sir.
10 minutes more? Okay, I think
Yeah,
that should be
yeah.
good.
Okay.
Probably I will wind up before that. Yeah, thank you.
There's no problem. Okay, sir.
Yeah. So summarizing an image. Now, so we will now we have done object detection. We have done some image analysis, right, on labeling of the images. Now, let's see if we can combine that knowledge with other options where we can create a summary ultimately for the whole thing, for the whole setup. So here we will again do this, run this, again an object detection. So we are using the image of the panda, I think in this case, right? Yeah. So let's see if it is able to tell us that a panda is eating something. So, oops, no such file. Okay, we don't have test image. Oh, okay. The path is not correct. So test image JPG. Okay, so now it is determining what are the different things that we have. I don't think there will be any cloth. I was actually experimenting with the human image. So, but I don't think there will be any clothing items in here. Let's see what does this have. Oops. Okay, so tensor, what about the results? No, sorry, results is tensors. What about the clothing items? Teddy bear. Okay, so yeah, it's probably just you can rename them as items. That's also okay. I was working using with some other images. So I had it. So yeah, basically what it did was it same thing. It took that image and tried to identify the different images in that. Now it's only identified teddy bear, so not that useful to us probably. Let's see if I can give it lungs and then what it gives us. Nothing. Wow. Okay, and then if we use the object detection again, so it will should be the same object detection .jpg. So it's probably not that well trained to identify like if you give it a x-ray, so it's not able to get that okay, that's only lungs or ribs or something. So here it chair, couch, person, potted, same thing. Yeah, we need this another library called MediaPipe for this. So probably you can install it now. Oh, there is a question. Okay, so if someone has shared a protracted model to detect some disease, it will be able to replicate the example we did for pose. Yeah. if we have someone has shared a protracted model to detect some disease, it will be able to replicate the example we did. It should. It should. Maybe we need to do some hyperparameter tunings or something to get the right results or accuracy, but it should. Also depends on the model, how good it is, right? If it's a good performing model, then yes. I don't see why it should not. If the input is good quality, model is trained well, and we know how to play with hyperparameters, then I think yes, we can. That's what the LLMs are also like this, right? Because when you so it's pre-trained. Now to create a RAG, you have to play with hyperparameter tuning, in the sense, what is the chunk size that I want? What is the indexing strategy that we want? And if so, that what is the similarity we want to use? Like here we were using cosine similarity. Can you use any other similarity to get better results? So like that. Yeah. So yes, activity detection and post detection using MediaPipe. So we'll again see what is. Let's see. So here it's I have kept it optional because you need to do some work on this based on pose landmarks. Like here we are kind of hard coded it, like, okay, if the result is pose landmarks, then you just say that person is running. But you can actually have more liberty or some control here, that you can read those landmarks and then define different activities, like is it walking, is it running, or is it sleeping, like I was sharing earlier. I was just thinking if I can print it. So let's see results. Okay, no, that should not be the case. Okay, let's try this. Okay, yeah, somehow it doesn't. Okay. What if I use this image? Does it? Interesting. Okay, probably my images are not the right match for this. But it should have this one, right? Let's try this one, because that is where we have a human being, and see if it is able to identify and that what my daughter is doing. Okay, yeah. So now we have some landmarks here. So basically it's giving you the coordinates of different points or the pixels, and then you can probably see if it's there are ways to define that it's a hand or it's a leg, and then based on the coordinates you can do some calculations that if the stride of a person is this much, then he's walking, and if the stride of a person is this much, then he's running, and if the location of the hands is like this, then he's doing something else. So like that. I have not developed it more because I didn't felt this is significant from a medical thing perspective. So, but I've kind of focused more on generating these labels in the summary. So, but yeah, you can definitely play around with it based on your interest. Yeah, also because this needed more work, in the sense that different identifying, okay, what are the pixel values, then where is the hand, where is the leg, all those things. So I just skipped it. but I wanted to give you a glimpse that something like this exists that you can use for activity detection. Okay, now let's see. So here we are trying to identify scenes or the environment, or the how is it? Is it city? Is it forest? Is it beach? Is it indoor, outdoor? What type of setting it is? And so that because that forms an important part of summarizing any object, right? That a person is working on, or a person is lying in the hospital, or is lying on the couch, or a person is walking outside. So those type of like if you want, a patient is taking a daily walk outside or not, so can that image help you to identify that, or can that video tell you to identify that? Or if there is, say, a device attached to the patient, and then based on these settings that is able to generate a daily summary and send it to a doctor that your patient has done this much of exercise. Basically, Apple iWatch is also kind of like that, but yeah, with some images and cameras, it can also give you the setting. So now once you have all these things, basically, I think I had items here, right? Yeah. So if you have, you can ask once you have all the top above things, like we have we identified what are the different items, what is the activity happening, let's say, what is the scene is, and based on that, we can give all those information to the LLM, and we can ask to generate a concise summary by using all that information. So see the okay, the summary depicts a person running indoors surrounded by a chair, couch, and a potted plant. Right. So this is a very okayish response. You can also ask it, okay, add description for each item in the image, like this. And then it should be able to give you more detail, showcasing a dynamic action surrounding a chair, indicating a comfortable living space. So basically, it is just generating out of the information it has. But the goal of this is to show you that you can club some information or details that you gathered before, combine them in a way, in a prompt. So this is basically a prompt for us, and then give it to the LLM model, and then it should be able to create a summary out of it, or basically whatever you want. Like if you want, create it in a bulleted point, right? Like, okay, give me response in bulleted format. So here, so it shows a person, chair, this. So you can kind of play around and use this or leverage this whole setting because using one model and give it an image and getting a summary, and there are LLM models which are doing that. That is one option, but then it does not gives you a lot of control. Having this step-by-step approach gives you more precision, in my opinion. I think going forward, these LLM models will also become very smart and will provide the good level of accuracy. So you can experiment with both the approaches and see which works best. So it takes a little bit of experimentation. Yeah, so this is kind of a full everything doing in one shot, like how we went to step by step. This is basically earlier, I don't think we did colors. Yes, right. And this one is also including colors in our analysis. So here I'm using the k-means to cluster the images and then create a image RGB vector for the input image, based on which it can determine the different colors in the image and then also create a summary. Let's see, no such file. Oh man, okay. Yeah, this path. So if you see, you should be, I mean, you should make sure that the path is correct. Okay, so the image contains following objects: teddy bear with color values this. Now, if you see, it tells us teddy bear, but we don't know like these are RGB values, right? So you can ask the LLM model to generate the summary in a more human readable format, in the sense, generate a human readable summary for us. Oh, okay, I didn't print that. Interesting. Let's take something from here. Let's copy this one. That showcases a combination of soft colors. The beer has light grayish hue. Okay, very bad. Complemented by dark shades of greenish black. Greenish black? Probably. So, and a vibrant teal. This color palette gives teddy bear a unique and appealing look. Okay. So it probably was not able to do a good job. We can, so if you see, there is this, okay, so we probably can play around with more hyperparameter tuning. One of them I can show you is the temperature. So temperature is basically the entropy, or the more, if it's 0, it's more deterministic in terms of, if you ask the same question multiple times, there is high probability it will give you the same answer. But as you increase this probability from 1 to 3, it will, there is high probability that it will not. Maybe let's see if it can show you that here. No, okay, probably because it's kind of straightforward, but temperature is like that. If you play around with it, it will. So 0 basically use the data that is we are giving it to. It relies heavily on that, and then generate the response. If you increase the entropy, it gives it more freedom in terms of using its own knowledge base, using the learning of the patterns it has from its knowledge base, the knowledge base for its pre-training, and then generate a response. So every time you run it, it can give you a different answer, basically. Okay, so here again, it was giving us these RGB values. Now I want to, I don't want this RGB values in this summary. So I just asked it to convert any RGB value into the actual color names, right? So now it does not give, it just tells me the color names: light gray color, gray, rich teal green. Combination of these colors gives Teddy a charming and cozy appearance, right? So it takes kind of combination of your data and the prompt to get to the right summary or the details that you want to extract out of an image. Okay, here a little bit more, like, can you list all the colors found in the image, use actual color names in place of RGB? So it will basically, now I'm getting the colors. You can you list all the say plants? I don't know if it identified any plants like bamboo or something. So I don't expect. Light gray, this is running indoors, and there are no plants present in the picture. So we need to do some better work in identification of the objects, essentially, so that it is able to find the plants or whatever we want to kind of do here. Right. So like this, you can kind of play around with these blocks and give it the images from your data set, and then see what you can how you can leverage this to create this. whenever you will make these calls client.chat completions.create, it will go to it is an OpenAI API. It will kind of call this GPT-4 Omni model and will try to query it, just like how you query on ChatGPT, right? Same, this prompt will go to it and then query it. So the key that I gave you enables that communication. I will have to remove it after this session. So your calls might fail, but you can always create your own account and then again just change the key in the environmental file here, and then you can run these web labs again. And web Jupyter notebooks again. You should be able to do so. But yeah, if you face any problems or any questions in these, or you want to do some experiments and need any help, you can feel free to reach out to me, and I can probably find time and we can connect and work with you on resolving any issues that you might see. But yeah, with this, I will end the session. I hope I have provided you some useful tools that will generate interest, and you will probably play around with these. For any of the, you can, these are not important in the sense from experimental purpose, because you already know if you can just get to the description, then this is just an LLM call. So that is where even if you don't have the key for the OpenAI calls, don't feel that you cannot work with this. You can still work with this because you already you don't need the key to find the scene or activity or clothing color detected already, because all of these are like pre-trained models that you can download how we have done here and run it on your local. So these don't need any API keys or anything. So it should so not having an OpenAI account should not set you back from experiment purpose. Okay, yeah, with that I will end this session. Thank you everyone for joining. I appreciate your time. And over to you, Nitin sir. Back.
Thank you, sir, for this valuable information you shared with us. Any question from participant side? I think 9 o'clock is there in US.
8 in the morning, sir. Right
8
now.
in the morning. That's fine. Yeah. Any question from participant side? After a 6-day long journey of the participants, please on your camera. All the participants are requested to on your camera so that we can take a group photograph with Shivam sir.
Oh, okay. Didn't thought about that.
All the participants are requested to on their camera. Sachin Gupta sir. I think sir is there.
Hello, Nitin sir, my camera is not working.
Okay, sir. Good evening, sir. Sachin sir, good evening. Our Dean Research and Innovation.
Hi, good evening. Thank you, Shivam. I was enjoying your deliberations very much. And I think I would have joined earlier, but there was another workshop going in mechanical for MATLAB.
Thank you, sir. Yeah, glad that you liked it. So that's a good.
I'll be able to continue with your work. Whatever you have shared today, anybody from me to whoever requires to work with these tools or with keys or even with a different API, not just OpenAI, maybe the Google API, I'll be able to help them out. if anybody requires. So I'll be able to continue what you are doing.
Great, sir. Thank you so much. Yeah.
Thank you,
And
sir.
yeah,
Thank
I'm
you.
always here for any help that I can do from my side. But yeah, definitely. Thank you.
Now, sir, our valedictory session is going on. So all are requested, and including Shivam sir, to attend the same.
Is it on the same bridge, sir, or is it different model?
On same time, sir.
Okay. Yeah, sure. Thank you.
Now this valedictory session, we start with this feedback session. So now, dear participants, we hope you had a rewarding and insightful experience during our 6-day online faculty development program on medical imaging in the third dimension, advanced techniques and clinical applications. We invite you to share your thoughts. We would love to hear about your key takeaways, insights, and experience from this faculty development program. Your feedback will be invaluable in helping us to improve and shape future programs. Please, any one of you, I think starts from,
Yes,
yeah,
Nitin sir.
yes,
Hello. Nitin
introduce
sir, am I
yourself
audible?
and yes, ma'am, yes, ma'am,
Hello.
yes, ma'am, you are audible.
This is Dr. Jolly Parik.
Yeah, Dr. Jolly Parik, ma'am, yes, ma'am.
Yeah, this is Dr. Jolly Parik from. Okay. This is yes, sir. Sir, this is Dr. Jolly Parik from Bharati Vidyapeeth College of Engineering, Delhi. And I really enjoyed all the sessions of this FDP. It has been a very learning and knowledgeable experience for me. The case studies that especially Pratha sir had discussed, and all the hands-on sessions that were conducted by speakers from Mentor Graphics and other like Amazon person, the speaker of the first day also. They were like very enlightening. And all these speakers had shared their knowledge with us, and it was like a great learning experience for me. Thank you so much for taking me in for this FDP at FDP. Really enjoyed everything. Thank you, sir. Thank you.
Thank you, ma'am. Thank you. Yes, any other participant from South India?
Hello.
Yes.
Hello.
Yes, ma'am.
Nitin sir,
Introduce
sir?
yourself. Yes.
Yeah.
Please, Arvind sir, introduce yourself.
Please turn on the camera, sir.
Yeah, am I audible, sir?
Yes, yes.
Yeah. So first of all, Dr. Nitin and all the organizing committee members, I'm really thankful to all of you for organizing such an interesting FDP. This FDP has been something different because most of the sessions, they were hands-on sessions. So I enjoyed a lot. Probably I have learned a lot about the CNN, GAN, and the fast eye concept. I hope in the future also you people will be organizing such kind of FDP. Thank you so much.
Thank you, sir. Thank you. Anyone else from South India?
Hello.
Yes, ma'am.
Hello, sir. I'm Tachiti Pimpe. I'm working as an assistant professor in computer department at St. Francis Institute of Engineering, Mumbai. And talking about the feedback, I always try to attend the FDPs that are relevant to my research. And when I found this one on a medical imaging, I knew I had to sign up, and it turned out to be a great decision. From the very first day, everything was very well organized. Both the practical and the theoretical session were insightful, and it really helped me to clear my doubts related to my research topic. So I learned several new techniques during this FDP, and I am excited to apply them in my research. So I would say a big thank you to the team of MIT New Delhi and all the experts who made this possible. And I truly appreciate the efforts that went into organizing such a valuable FDP. Thank you so much, sir.
Thank you, ma'am. Thank you. Yes. Any other participant?
Hello, sir.
Hello.
Yes.
Hello.
Yes, sir.
Yeah,
Yes,
go
ma'am.
ahead. Yeah, Dr.
Yes, ma'am.
Yes, sir. Myself, Antim Dev Mishra. I am Dr. Antim Dev Mishra from Sutant University, Gurgaon. So
Okay, sir.
I'd like to share my experience attending this FDP. All the sessions have been highly enriching, and all the speakers explaining their topics exceptionally well. But a special mention, I would like to mention special things to speakers, those who have explained hands-on learning segments, especially Dr. Rajesh Prabhakar, founder-in-chief of Data Advanced Lab, and today's session, Mr. Ravi Kant, for their outstanding session. So I would like to express my gratitude to Nitin sir, because I have attended multiple FDP, Atal FDPs, but this FDP is not like a faculty development program. For me, it's like completing a course, because there are many sessions that was very very innovative. So we can start from scratch and complete a project. So thank you very much, all the organizing team, and I would love to attend a similar FDP in future. Thank you so much.
Thank you, sir. Thank you. Yes.
Hello.
Yes, ma'am.
First, I'm Dr. Mananjani from ADGIPS Delhi. First of all, I would like to thank all the coordinators for this wonderful organization of wonderful FTP. It was very knowledgeable, dedicated sessions on ethical implementations of artificial intelligence and other deep learning models in medical imaging sectors, facilitating all the candidates with hands-on experiences and everything, fostering ongoing knowledgeable sharing developmental processes. I would like to say, and I would like to thank the organizing team for the wonderful opportunity given to all the participants. It was a resounding success. It provided participants with comprehensive understanding of the latest advancements in medical imaging, along with the very conceptual knowledge in deep learning environment for medical imaging as well. The key point that everyone shared is the hands-on experiences, which is a very novel thing. You all provided us with such conceptual knowledge with hands-on experiences. So I am beyond thankful for providing us with such knowledgeable tools, such knowledgeable media, and everything in which will help us in multidisciplinary technologies as well. Thank you so much.
Thank you, ma'am. Thank you. Yeah. Anyone else who want to discuss their views and any scope of improvement for the FDP Faculty Development Program?
Good evening, all of you.
Yes. Yes, sir.
Sir, all the sessions were so good, sir, and informative. And I think all will be very benefited from the all the sessions, and very interesting as well. And all the documentary and all the lectures so informative. And thanks to all the speakers and as well all the systematic manner and arrange all the on time. So thanks to all the teams members also. Thank you, sir.
Thank you, sir. Thank you for this appreciating words.
Thank
you to all of you. Any participant, anything more want to share with us on this platform?
I myself, Jaya Patan Shetty from SG Balakundri of Engineering College, Belgaum, that is Karnataka. So I
Yes,
thank
ma'am.
all the coordinators for sharing the knowledge on deep learning and image analysis. Thank you all the coordinators.
Thank you, ma'am. Thank you.
Okay, sir.
I think now start with our valedictory session. The conclusion of one chapter often marks the beginning of many new journeys. With this sentiment, we bring a close an extraordinary, enriching, and unforgettable valedictory session. On behalf of Maharaja Agrasen Institute of Technology and the Department of Electronics and Communication Engineering, I extend our heartfelt gratitude to AICTE and the Atal Academy for getting us the privilege to host this 6-day online faculty development program on medical imaging in the third dimension, advanced techniques and clinical application. It is a privilege to have with us visionary leader who has consistently driven innovation and excellence in education. I now invite Professor Sachin Gupta, Dean Research and Innovation, to share his invaluable insights on the importance and impact of faculty development program. Sir, please.
I guess my camera isn't working. I tried opening it.
Two officer.
Am I audible, Nitin sir?
Yes, sir. Yes, sir.
Okay. So medical imaging is a field where I mean there are immensely potential applications available, and I'm glad to see that our electronics department under the leadership of Dr. Sunil Mathur and Dr. Neelam have initiated these deliberations. And I'm looking forward for almost all of the people, because we have Professor R.S. Gupta also, who can help everyone with the research. As far as the AI domain is concerned, I'll be very glad to help any one of you continue your journey, which you have started with this FTP. Thanks to Nitin and Swati ma'am for initiating and proceeding with all of the deliberations, so many sessions across 6 days, so many well received speakers, and looking at the feedback which you have received for the conference, I am very happy to see that people are appreciating it so much. Thank you so much.
Thank you, sir. Thank you.
Thank you, sir.
विद्या नाम नरस्य रूप दिकम प्रचत्र गुप्तम धनम विद्या भोगकारी यश सुखकारी विद्या गुरुनाम गुरु विद्या वंदुजनो विदेश गमने विद्या परा देवता विद्या राजसु पूजिता ता धनम विद्या विहीन पशु। वास्तव में केवल ज्ञान ही मनुष्य को सुशोभित करता है। यह ऐसा अद्भुत खजाना है जो हमेशा सुरक्षित और छिपा रहता है। इसी के माध्यम से हमें गौरव और सुख मिलता है। ज्ञान ही सभी शिक्षकों को शिक्षक है। विदेशों में विद्या हमारे बंधुओं और मित्रों की भूमिका निभाती है। ज्ञान ही सर्वोच्च सत्ता है। राजा महाराजा भी ज्ञान को ही पूछते हैं, वह सम्मानित करते हैं, ना कि धन को। विद्या और ज्ञान के बिना मनुष्य केवल एक पशु के समान है। Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special valedictory occasion of this 6-day faculty development program. I would like to thank our Dean Research and Innovation, Professor Sachin Gupta sir. I would like to express my profound appreciation to Dr. Nandkishore Garg ji, founder and chief advisor of Maharaja Agrasen Technical Education Society. and Mr. Vinit Lohia ji, Chairman of Maharaja Aghasin Technical Education Society, for their unwavering support and visionary leadership. A special note of thanks goes to Professor Neelam Sharma, Director, Maharaja Aghasin Institute of Technology, for her constant encouragement, keen interest, and for providing the platform that enabled the EC department to bring this program to Fruiton. Additionally, I extend my gratitude to Professor J.V. Desai, Director General of MEIT, for his invaluable guidance and support throughout this journey. Our heartfelt thanks goes to Professor Sunil Kumar, Head of the EC Department, the dedicated faculty members, and all participants whose enthusiastic involvement and commitment have been instrumental in making this valedictory session a resounding success. A special acknowledgement goes to Dr. Swati Sharma, co-coordinator of the Atal FDP, whose active engagement and steadfast dedication have been pivotal to the seamless execution of this program. I also wish to commend the tireless efforts of the faculty and staff of the EC department of MEIT. Your hard work, especially during the final stages, and your readiness to overcome challenges have been truly inspiring and commendable. I sincerely thank my colleagues Dr. S.K. Kundu, Mr. Vaibhav Nijavan, Dr. Preeti, Mr. Rohit Lakhane, Dr. Sumedha, and many other faculty members, Dr. Divya, Dr. Rajni, Dr. Anubha, Dr. Anamika, Ms. Neeraj, Ms. Kanika, Ms. Avilasha Gokhale, Ms. Shalu, for successfully comparing the event. Participants endorsed in their feedback that such FDPs should be arranged regularly. Participant opinion that the faculty development, this type of faculty development brought practical knowledge of the subject to them. They felt that the delivery and the presentation of the resource person were very good. If time is money, then you have spent millions for us, particularly for the participants. Thanks to all of you for making this event successful. We extend our sincere gratitude to the distinguished speakers who shared their profound knowledge, especially Shivam sir, and expertise, significantly enriching the collective learning experience of all participants, patience, presence, and active participation throughout the faculty development 6-day faculty development program is remarkable. Thank you all once again. Thank you very much. And after this session, we will start with our this feedback. Written feedback is there through Google Sheet. We will share soon, and thereafter queues is there from 8 to 9 p.m. All are requested to attend the queues. If anyone want to say something, I think one of the participant is raised his hand. Okay, thank you to all of you. We will share one documentary of Maharaja Agrasen Institute of Technology during this time, and I will share the queues link. You all are requested in a limited time period. You all are completed the queues. Thank you.
वाली तकनीक शिक्षा प्रदान करने के लिए समर्पित थे, जो ईमानदारी, उद्यमशीलता और सामुदायिक सेवा का प्रतीक थे।
दिल्ली सरकार में इंद्रप्रस्थ विश्वविद्यालय बनाने के लिए जब हम लोग कोशिश कर रहे थे, तो उस समय कई अफसरों ने कहा कि यूनिवर्सिटी तो आप बना लोगे सर, कॉलेज कौन आएगा आपसे एफिलिएट होने, क्योंकि दिल्ली के अंदर ज़मीन की समस्या है, साधनों की समस्या है, तो बहुत मुश्किल काम रहेगा। तो उस समय हमारे कई मित्रों को भाई एक तो मैं प्रेरित करूंगा समाजों को, तो सिख समाज का काफ़ी योगदान है दिल्ली की शिक्षा में। हमारे समाज का महाराजा अग्रसेन समाज का है, ब्राह्मण समाज, ये 3-4 समाजों को मैं कोशिश करूंगा कि ये अच्छे इंस्टीट्यूट खड़े करें। मेरे मित्रों से बात की और उन मित्रों से बात करके भाई एक संस्था बनाते हैं जिसमें एक इंजीनियरिंग कॉलेज शुरू करें।
आज महाराजा अग्रसेन टेक्निकल एजुकेशन सोसाइटी मेट्स दिल्ली में महाराजा अग्रसेन इंस्टीट्यूट ऑफ टेक्नोलॉजी, महाराजा अग्रसेन इंस्टीट्यूट ऑफ मैनेजमेंट स्टडीज, महाराजा अग्रसेन बिजनेस स्कूल और महाराजा अग्रसेन विश्वविद्यालय बद्दी हिमाचल प्रदेश जैसी संस्थाओं के द्वारा अत्याधुनिक सुविधाओं और व्यावसायिक पाठ्यक्रम के साथ शैक्षिक उत्कृष्टता के एक स्तंभ के रूप में खड़ा है।
डॉक्टर मुरली मनोहर जोशी जी जो उस समय शिक्षा मंत्री थे, उन्होंने जब ये कहा कि मैं बैठा हूं, कोई दिक्कत नहीं आएगी, शुरू तो करो, और हमने शुरू किया। और जब इस नए भवन का उद्घाटन माननीय अटल बिहारी वाजपेयी जी से करवाया तो उस समय लगा कि हमारी मेहनत का कोई पहचान तो बनी। क्यों अटल बिहारी वाजपेयी जी से पहले मैंने जहाँ ये इंस्टीट्यूट शुरू किया था गीता स्कूल सुल्तानपुरी, वहाँ हमने रजत जयंती में अटल जी आए थे और जब उनको ये बताया कि वहीं से शुरू होकर हम यहाँ आए हैं तो कि आगे बढ़ो गर्ग जी, आप में बहुत क्षमता है। अब उनके कहने से ही हमने मैनेजमेंट ऑफ इंस्टीट्यूट भी शुरू कर दिया। भगवान की कृपा से वो भी अपना एक स्थान, और उसके अंदर हमारे कई मित्रों ने कहा कि जर्नलिज्म शुरू करो, और हमारे कई बड़े अटल जी ने भी कहा कि अच्छे जर्नलिस्ट, राष्ट्रवादी जर्नलिस्ट आप पैदा कर सकते हो आप उनको, तो हमने जर्नलिज्म का कोर्स शुरू किया। फिर लोगों को अच्छे वकील भी हम देश को दें, अच्छे जजेस दें, तो हमें लगा कि हमें लॉ भी शुरू करना चाहिए। और एक पहाड़ों पे पढ़ने का शौक है, उसे देखते हुए हिमाचल में महाराजा अग्रसेन यूनिवर्सिटी, जिसका उद्घाटन आदरणीय राष्ट्रपति प्रणब मुखर्जी ने किया। तो प्रोत्साहन मिलते रहे, आगे बढ़ते रहे।
पिछले कुछ वर्षों में मेट सोसाइटी की संस्थाओं ने कई कीर्तिमान हासिल किए हैं। हजारों योग्य स्नातकों का प्रशिक्षण, तकनीकी शिक्षा में शीर्ष रैंकिंग और अग्रणी उद्योगों के साथ सहयोग भी स्थापित किया है।
महाराजा अग्रसेन इंस्टीट्यूट NBA accredited इंस्टीट्यूट है। इसके 3 प्रोग्राम्स बीटेक, कंप्यूटर साइंस एंड इंजीनियरिंग, मैकेनिकल एंड ऑटोमेशन इंजीनियरिंग, इलेक्ट्रॉनिक्स एंड कम्युनिकेशन इंजीनियरिंग, ISO सर्टिफाइड है। NIRF की रैंकिंग है 201 और 300 के बीच में। बैंड प्रॉमिसिंग इसको अटल रैंकिंग के थ्रू मिला हुआ है। 35 MOUs हैं इसके, जिसमें कि 3 इंटरनेशनल MOUs हैं और ये ग्लोबली रिकग्नाइज्ड है। रिसर्च बेस्ड हम लोग बहुत सारा काम करते हैं। जो बड़ी बड़ी ऑर्गेनाइजेशंस हैं जैसे AICT हो गया, DRDO हो गया, इस तरह की ऑर्गेनाइजेशंस के साथ में हम लोग कोलैबोरेशन भी रखते हैं और इनके साथ बहुत ज़्यादा रिसर्च प्रोजेक्ट्स भी करते हैं।
महाराजा अग्रसेन इंस्टीट्यूट ऑफ मैनेजमेंट स्टडीज़ नाम के पौधे को 2003 में महाराजा अग्रसेन टेक्निकल एजुकेशन सोसाइटी द्वारा रोपा गया। तब से आज तक ट्रस्टीगणों, अध्यापकों और विद्यार्थियों द्वारा इस पौधे को बड़े प्यार से, मेहनत से, निष्ठा से एवं विवेक से सींचा गया और आज ये पौधा एक वृक्ष का रूप धारण कर चुका है। आज हम NAC A++ हैं और हमारे विद्यार्थी हर क्षेत्र में आगे बढ़ रहे हैं।
महाराजा अग्रसेन संस्था ने ग्रैंड थॉर्टन, जो दुनिया की 6 बड़ी कंपनियों में काउंट होती है, के साथ कोलैबोरेशन किया। उस कोलैबोरेशन के अंतर्गत एक महाराजा अग्रसेन बिजनेस स्कूल को एस्टैब्लिश किया गया। उसके बाद AICT ने उसको मान्यता भी प्रदान की और अब यहाँ पर 2 साल का प्रोग्राम कंडक्ट किया जा रहा है। ये प्रोग्राम केस स्टडी बेस्ड मैथडोलॉजी से पढ़ाया जाता है। इसमें इंटरनेशनल कोलैबोरेशन होने शुरू हो गए हैं। पिछले साल बच्चे दुबई गए थे, इस साल न्यूजीलैंड की एक बड़ी यूनिवर्सिटी के साथ करार किया गया है। इस तरह से इंटरनेशनल कोलैबोरेशन और केस स्टडी बेस्ड मेथड के साथ में एक इंटरनेशनल लेवल का प्रोग्राम इस संस्था में अब चल रहा है।
अकादमिक शिक्षा से परे मेट्स राष्ट्र प्रथम की भावना के साथ समाज को वापस देने, छात्रों को सामुदायिक सेवा के कार्यों में शामिल करने, सामाजिक जिम्मेदारी और नेतृत्व की भावना पैदा करने में विश्वास करता है।
हमने 2 रोल मॉडल लिए थे, मदन मोहन मालवीय जी का हिंदू यूनिवर्सिटी और महात्मा गांधी द्वारा स्थापित रोहतक में वैश्य इंस्टीट्यूशंस, जिसके अंदर शिक्षा का व्यवसायीकरण ना हो, शिक्षा सामान्य लोगों को उपलब्ध हो और जिसके अंदर राष्ट्रवाद को, नेशन फर्स्ट, यह भावना लेकर चलने वाले नए जो मानव हैं, जो नए शिक्षित लोग हैं, वो हम समाज को दे सकें।
आज जब हम अपनी रजत जयंती यानी 25वीं वर्षगांठ मना रहे हैं, हम उत्कृष्टता की अपनी विरासत पर विचार करते हुए उज्जवल भविष्य की आशा कर रहे हैं।